The focus of this video is rotational symmetry in geometry. A figure in a plane has rotational symmetry if the figure can be mapped onto itself by a rotation of 180 degrees or less about the center of the figure, called the center of symmetry. Note that the rotation can be either clockwise or counterclockwise. For example, this figure, we have it has a rotational symmetry of 72 degree that maps the figure onto itself. What does this mean? Let me change this to another figure like this. So this figure, it has a rotational symmetry of 90 degree, which is, the condition is it has to be less than 180 degree rotation. When a figure maps onto itself by rotation, so now in here, for example, if I rotate this figure, then when this figure is going to exactly overlap, it is right now it is overlapping. So this figure, the green one, is the when I rotate this one, it overlaps again after making an angle of 90 degree. Let us see the angle. This is the angle it makes. So that means its rotational symmetry of this figure has 90 degree. The rotational symmetry is 90 degree. If I continue moving further, it will match again, but it will match again exactly on when the angle of rotation is 180 degree. So this figure has the least angle of rotational symmetry 90 degree, and then it has 180 degrees. But the condition is it should be less than 180. What happens if I continue moving this? Watch. When I continue moving this, the angle of rotational symmetry, which was shown by this arrow, is not increasing. It should increase, but no, it is going back. And it matches when the angle of rotation is 90 degree positive. So the angle, that is what it says here, the angular or rotational symmetry is 180 degree or less. It's not going to be more than, like when I moved from here to this spot, it looks to me that it has moved 270 degree, but we are not going to count this as a rotational symmetry. The rotational symmetry has to be 180 degrees or less. So in this case, we can see is this. It is less than the least rotational symmetry is 90 degree for this figure, and the next rotational symmetry is the multiple of the least one, which is 180 degrees. So what happened if I have a figure which is not like, it has four parts. If I have a figure which is like this, now in this case I have, let me reset to the original one. Now here is this. Now in this case, the rotational symmetry is going to be, when I move, let me show you the angle. The angle right now is 29 degree, and I'm going to move it. If I keep moving, so the rotational symmetry of this figure is going to be 72 72 degrees, the least one, and then if I continue, it makes another symmetry which is going to be 72 degree addition, so that makes it 144 degree. But if I go the third, another angle if I make, though it will continue, but it's not going to go beyond 180, the arrow will start going backward. So if I go, that is I have up to 180, you see 180, but if I go, it is going backward. So the rotational symmetry is going to be any angle which is less than 180. Now this figure has the least rotational symmetry is 72 degrees, and the second one I have 144, which is the multiple of 72 degrees. How do we find these rotational symmetries? What decide to have the rotational symmetry? The rotational symmetry, that is what we will discuss a little later. As I said here, the rotational symmetry can be either clockwise or counterclockwise direction. So this one, when I'm moving in this direction, then I'm moving as a counterclockwise direction, so angles are positive. But if I say what is its clockwise rotation, so we have to find the other angular rotation, and that we can find it. For example, if the least rotational symmetry of this figure is 72 degree, which is a positive, which is counterclockwise, if I say how much is the clockwise rotational symmetry, so what we can do, we can find it as by calculating. So we can find this is going to be this angle is 72. So if I go in the opposite direction, clockwise direction, so what we are going to do, we'll do 72 degrees is the counterclockwise, and if I subtract 360 degrees, and that will give me this angle in this direction, which is a clockwise direction. So we are going to subtract this, so you can subtract 360, take away 72, that will give me a positive number. We will subtract later. So you get 8 here, and you get what, 8 there, and then you get what, 2. So that will give you 360. So the counterclockwise, the angular rotational symmetry is going to be, the measure of angle is going to be 288 degrees. This angle is going to be 288 degrees. So we can find this these angles. Now the question is, how do we find these angles? So let me go and see the pattern. When we have 5 leaves, or 5, the figure has 5 sides, it is 72 degrees. Let us make it, I'm going to make it 6. So what happens if it is 6? So the angular symmetry is going to be, when I move it, so you can see the angular symmetry is going to be 60 degree. Let me do it one more time. I'm going to move this, and as I move this and I want to measure the angle, the angular symmetry for this one, you can see it is, the first one matches a 60 degree. The second one is going to be 120. It is a multiple of, you can see that, and the third one is going to be 180, because 180 is also multiple of 60. So that is how we are going to get this one, the third one. But beyond 180 is not going to be. That is the maximum it can go. The 180. After that, you will see it goes back. So this is what the thing is. Now we have to find out how do we get the minimum rotational symmetry. You can see when it is 6 leaves, it is 60 degree. What happens when it has 6, 7, 8? You see, when it is 8, it is 45 degree. 9, 10, 11, we can move and we can see how much is going to be the rotational symmetry. Let us work it out. Now, when you look at this way, this figure, the figure looks like it is enclosed in a regular polygon of 4 sides. What I mean is this: if I really try to draw a line like this, this figure is enclosed in a regular 4-sided polygon, which is a square. So the rotational symmetry is going to be 360 degree, because this is the whole circle, divided by 4 gives me 90. So if you have a figure which is enclosed in a square, the rotational symmetry of that figure is going to be 360 divided by 4, which gives you 90 degree. Likewise, let me make another figure when we have 5 sides. Let us make it 5. So now this one, it is a pentagon and it is a regular. So it is a regular pentagon. You can see 1, 2, 3, 4 and 5. So this is a pentagon. So that means I am going to divide 360 divided by 5, which gives me 72 degrees. So that is number of sides. Whatever the sides you have, you just divide, and that gives me the angle of rotational symmetry, which will be the least. I can go multiple of those, but I cannot exceed more than 180 degrees. Likewise, if I have 6, it is going to be 60 degree, because it is hexagon. 7, 8 is going to be 45 degree, because there are 8 sides, so 360 divided by 8. That is what it is written here, that the figure looks like it is enclosed in a regular polygon of 8 sides. The smallest rotation that maps the polygon onto itself has the measure, which is 360 divided by 8, which is 45 degree. So it is not really difficult to find what is the rotational symmetry if you understand how to find the least rotational angle which maps the figure onto itself. The only condition one must remember that the rotational symmetry cannot go, the angle of rotational symmetry cannot go beyond 180 in any case. It has to be less than 180, and you can see it here why it is less than 180. Right now it has 4 figure, 90 degrees, the least rotational symmetry, and then when you keep moving it is going to be 180, but it can't go beyond that. It goes back. So that is why it is this. I hope this demonstration helped you to understand what is rotational symmetry and how to find the least of the rotational symmetry.